Okay, so we are going to cover leak testing method as part of basic examination syllabus. So why leak testing is required? So if you've seen most of the accidents, so especially if you've seen your case when you are like a child, that time you might have seen the articles on the newspapers about the gas leakages or cylinder explosions. So or even in your oil and gas also some kind of oil leakages, all these things. So frequently we used to notice, but nowadays there were many reductions on these type of accidents because of the frequent checking and also the pass of leak testing. If you've seen last time, in order to use LPG cylinder, we people used to afraid, but now we the same LPG cylinders we are keeping for our cars, autos, rickshaws, and different vehicles also we are using, and everywhere we are using the cylinders without any difficulty because the safety aspects and also the testing, frequent testing. So you can see all these are all still there was some leakages and sometimes some accidents occurring. So to ensure that the safety requirements and inspection requirements, we need to perform the leak testing. So you can see here in the early days, so the aircraft also got this kind of cabin related issues, like a fuselage got broken. Okay, so like every cabin, every aircraft, they used to do the leak testing because they need to maintain the required cabin pressure. So when you're flying, like they used to announce like a gap when pressure drops, automatically the air supply will start. So something like they used to announce right in the aircraft. So these are all ensuring the required pressure difference, meaning they'll maintain the pressure boundaries. So this one is in 1988. Okay. So coming to the industrial environment, so you might have seen these kind of leakages in the industrial environment, especially if you have insulated items. So sometimes we cannot see visually, but the insulation wetness or the discoloration or maybe some kind of bad smell. So we can feel differently. So if you see in your house last time without having these concrete structures, all these things. So when we have houses like this, so used to leak, especially in the rainy season. Even sometime your air conditioner also used to leak because of some issues, blockages, all these things. So it starts leaking. So these are all like some common points, and nowadays the data also is leaking. So if you see in your most of the business, everything is based on the data leaks. If you see Facebook, WhatsApp, Instagram, or Google, all these things, so they used to leak the data of their clients. Like they used to collect a lot of data and they used to share with other companies all these things, and they used to make a lot of business, right? So this guy leaked the data of US, right? So the government. So this is also one kind of leak, WikiLeaks, right? And also you see the scams, all these things. So they're trying to leak your sensitive information like credit card details, all those things, bank passwords, personal data. So if you see the ships mainly we need to test for any kind of leakages. We need to ensure the system is completely leak proof. And if you see your tap waters, all this, still we used to see all these things. But why it is so important in industrial environment? Not because of the quantity of the gas leaking, or not because of the liquid that is leaking. For example, if you see the tank farm or any storage tanks or any industrial environment, maybe every day 1 liter of oil is leaking. But for the plant owner, that is not a significant amount. 1 liter is not a big amount to him. Maybe $5, $10 is not a big amount. But the problem is safety issues. So if someone smoking nearby, it catches the fire, the entire plant will explode. So that's why in the safety aspects, like if some poisonous chemicals leaking, so the people working nearby died, right? So fatalities. So then the government will impose a huge fines, and sometimes they will force them to shut the plant. So that's why this small leak is very important in terms of industrial environment. That's why asset owners, they used to arrange all these inspections. So they don't have any love towards the entity or any other inspection activities like API inspections, all these things. Why they are timely maintaining all these things? Because they want to protect their assets. They want to get rid of all these kind of offenses or fines. from the governments, and they want to maintain a good reputation in the market, and they want to increase their profits, production, everything. So that is the reason why they are implementing all these inspection plans, strategic plans. All this is the main idea is to maintain their assets in a safe condition and to maintain their profits in an exponential manner. So the reasons, but outside world, so they'll tell these reasons to prevent loss of valuable material. So here maybe your chemical like petrol, diesel, it may not be that much expensive, but when it catches fire, then the entire plant will explode, right? Because of that, they are saying this is a like valuable material. Sometime if any poisonous gas like H2S or any other gases leak, so people die. Then again, if they sue the company, then they need to spend $1 million. So that is also making this loss of material as a most valuable one. And to prevent hazardous condition or contamination, sometime in radiation leakages, if you see the nuclear plants in Japan, I don't remember the name. Like last time, because of the tsunami and earthquake, so one nuclear facility got affected. So still the radiation leakages going on. They shut down the plant, everything. So that is a kind of radiation leakages. Even when you are doing RT, why we need to use the survey meters, all these things to check the radiation leakages or any contaminations, and to ensure proper assembly by detecting a missing or faulty component. Best examples, if you see your spacecraft or any aircraft, all these things, what they do, they will pressurize and they'll test before it's flight. And also if you see your pressure vessels, boilers, even your pipelines also, so before starting operation they'll do the commissioning, right? So during the commissioning stage, so they'll engage the third party inspectors and they'll do a line check, and they will pressurize with the medium, and they will test for any small leaks. Most of the time they'll use a helium mass spectrometer to ensure the system is completely leak proof, but there is no absolute leak proof. So we cannot say like 100% leak proof. Any system you take, always there is a small amount of leakage occurs. Even if you see the corporate companies, even though they have a security, they have the access card system, and they lock all the laptops, everything, but still the data will leak. Small quantity of data will leak in other formats. Best example, if you see the iPhone, we think like iPhone is a very safe to use, or but if you've seen one video recently, like iPhone also they can hack. Within seconds they can hack that one also. So what I'm trying to say here, there is no absolute system like completely free of leaks. So always we need to use a word called as a leak rate. Maybe you can tell the leakage rate is very small compared to like for example, every day 1 liter is leaking. Instead of that, if you are saying, instead of so if you are saying like 100 ml leaking for 10 years, so you can feel the difference, like one day 1 liter is leaking or 100 ml quantity is leaking for 10 years. So meaning every day one drop is leaking, so every day 1 liter is leaking, so you can see the difference. So 1 liter means very big amount, one drop is still considerable amount. But if I say one drop is leaking for 100 years, then you can feel like the system is a very less leakage rate. So the system is like completely leak tight, because one drop, very small amount, that is leaking for over 100 years of period. So that's what the leak rate comes into picture. So they will tell very small quantity is leaking per second or per year or per day. That is what we call as a rate, like a hourly rate. So how much your overtime rate per hour, you are charging $100 per hour. So same way here also, leakage, how much quantity is leaking, so per hour, that is what we call as a leakage rate. So leak testing is frequently performed on a finished assembly to ensure the leak tightness as a finished product. So main item is to ensure the leak tightness. If you see your food packaging system, water bottles or oil containers, anything, even your aircraft cabin pressure, all these things, everything, they will ensure the leak tightness. So when they close the door, so the barometer that will show you the pressure, if there is a pressure drop, then immediately they call for something. Even your vehicle tires also, we are checking the air. So if any drop, then immediately we'll check, refill the air, right? The same thing. So most of the time is to ensure the leak tightness. Then coming to the safety hazards, so danger of implosion or explosion. If you pressurize the system, there is a chance of explosion. If you are dealing with a vacuum system, then we call it as an implosion. So explosion is for pressurized systems, implosion is for vacuum-based testing systems. And the tracer gas, so sometimes you may need to fill with some chemicals in order to test the cylinders. Like for example, if you see the LPG cylinders, all these things, so once you fill, then after you are checking, but by mistakenly during the testing someone starts smoking, so maybe if there is a leak it catches fire and leads to explosion. So like a flammability of gases, but instead of that gas if they use air medium, so if you smoke also nothing will happen. So sometimes the chemicals or the tracer gases which we are using is dangerous, so if we inhale the gas we'll get some kind of health issues as well. So asphyxiation means because of this inhaling, like during the testing, if some gases are leaking, if we inhale, so it will give some kind of respiratory issues. That is what we call asphyxiation. And poisoning and freezing, especially when you are dealing with the cryogenic systems. Like if you are testing with liquid nitrogens or any other chemicals that maintain at minus temperatures, so leads to freezing. So you can see here these kind of liquid nitrogen related things leads to freezing. So that is why the performing of leak testing is important. But one funny thing in the NDT market is those performing this leak testing, they don't know anything about its training requirements. They don't went through this proper qualification system. They don't even used to hold level 1 or level 2 certificates, and even that company or that particular level 3 also don't know anything about leak testing certification schemes. Even they don't create any like SNDTC or any level 2 certificates. They just give some training and they'll explain them how to do that, and these people will do blindly the testing. Most of the shipyards or most of the fabrication places everywhere, they used to do these kind of practices. They don't know anything about regarding the qualification process. They just use the normal technicians and they'll just give 1 or 2 days training, and that person will do the leak testing, especially the vacuum box leak testing and helium mass spectrometer. Most of the time the client also don't know anything, and the NDT supplier also do not provide any trainings or any proper qualification schemes. So they just give some training certificate from the manufacturer, or maybe in-house training certificate. They don't really qualify them through the examination, training and experience base. So that is a problem with the industry. But when it comes to nuclear industry or aerospace industry, some kind of automobile industries, they may be they'll give the training for the operators through the manufacturer. So when they purchase the equipment, the manufacturer will provide some kind of training, but it will not cover the SNDTC requirements. So coming to the definitions, a low leak is nothing but a hole or void in the wall of an enclosure. So if I say like the company is a very safe company, so not a small information is leaking, then we will say like this company is maintaining their boundaries or enclosure. So everything is within that company, like patent rights, all these things, or any drawings. Or best example, if you see the military, so military secrets, so within their boundaries. But sometimes you may see the news articles saying that some small information is leaked out. So meaning there is a small hole or there is some loophole. So maybe one officer took some amount of money from the enemies or something, so he leaked the system. So something like if something is having a passage from high to low, so is called as a leak. So leakage, as I told, right, leakage is nothing but the measurable quantity of fluid, like whether 100 ml or 10 ml, 1 drop, 10 drops. So that is nothing but the quantity we call as a leakage. Leakage rate is nothing but how much quantity is leaking per second or per unit time. It can be per day basis or per yearly basis or per second basis. For example, if I say like 1 drop is leaking for 1000 years, so I'll say leakage rate is very small. But if I say 1 liter is leaking per hour, so 1 liter per hour, so too much quantity is leaking, especially in the kitchen area, toilet areas. Most of the time water leakage is rate is very high, so every day 1 liter 2 liters is leaking. But the same thing if you implement in the industrial environment, so lead to accidents. So that's why they ensure only 1 drop is leaking for 100 years. So that kind of leak tightness they try to ensure. That's why they'll double check with this helium mass spectrometer, and they'll perform. The next one is a leak detector. So a device for detecting, locating or measuring, or a combination thereof leakage. So you are using some devices to detect. So to detect and locating or measuring, sometime your scope of work is just to identify the leak location where it is leaking, and then locating exact point, exact location, and then measuring. So if it is within the small quantity limits, then we can accept. Best example, if you see the repair shops, cycle repair shop, motorbike repair shop, they'll do the punctures, right? So if there is a puncture, so air is leaking, so they must locate it and they need to remove that leak. So they use a patch and they close it, then only it can withstand the air. But if you seen sometime, like when the tire got aged, so what happens, there will be a small leakage through permeation, or because of the heat, maybe the rubber tire will leads to expansion or something, so you may have a small leakage. But if it is within the limits, we just ignore. But if it exceeds certain limits, then we need to replace the tire. So something like a detection, like inside the confined space, if you want to work inside the confined space, they'll use the gas detectors. They want to check whether any poisonous gases inside. So that is based on your requirements, based on the work to permit system requirements. Okay, 1 second. Okay, so then coming to the leak testing categories. So mainly they divide into three categories. One is a leakage measurement. So if you cannot control it, if you cannot stop it, you can just monitor or you can measure how much quantity is leaking, and then you can pinpoint the location. So especially if you have any buried lines or insulated lines, so we need to pinpoint the location so that we can remove the insulation and we can close the leaks. And leak monitoring, if in the industrial plants, like some gases are very difficult to control, so even though you try to ensure the leak tightness, but still there is a small quantity of gas leaking, so you need to monitor that leakage. If it exceeds the levels, then we need to take some corrective actions. Even if you see your radiographic testing, so when they are doing RT, so the radiation leakage is occurring, so that's why we put a barricade and we monitor. If the radiation level is within that limits, then we can safely work outside the border. But if it exceeds certain limit, then immediately we need to evacuate, or we need to turn off the camera, or we need to take some precautionary actions. So sometimes like if still there is a leakage, so we just need to double check what, like how much quantity is allowed to leak. If it is within the limits, we can accept. So leak measurement, so measurement of total leakage. So leak testing is nothing but one kind of entity method for detecting, locating or measuring the leaks or leakage rate. So we can use either pressurized system or evacuated system. So there are two ways. One is pressurizing the component, or another one is applying a vacuum. So we can use evacuated system. So two ways of doing the leak testing. Leakage monitoring. So it's like a long-term continuous test, especially if you see some MNC companies. So especially the IT team or cyber security team. So what they do, they'll just keep an eye on this stuff, like overall collecting the data, sensitive data, sharing here and there. They'll just monitor for a period of 1 year, 2 year, and one fine day they will catch the candidate and they'll show all the evidences. Even if you see the police investigation, all these things, even though they know, but they won't do anything immediately. They'll just monitor for a period of time. Once they get solid evidences, then they'll get into action. Same thing occurs here. Leakage monitoring, best example, confined spaces. You need to monitor the gas levels, oxygen levels. So what they do, every 3 hours once, every 4 hours once, the safety people, they'll check the gas levels. If it is within the limits, they'll continue the permit, otherwise they will evacuate the people. So that is what, like, monitoring. So most of the time our main intention is to locate and fix the leak sites. If something is leaking, so your intention is to identify and fix the leak. Okay, so that you can bring the leakage level to the acceptable value. And there are n number of techniques with the leak testing. So you can see here bubble leak testing or ultrasonic leak testing, acoustic leak testing, pressure, ionization, conductivity, radioisotope, pressure change, mass spectrometer, many techniques available in the market. And this technique is usually more sensitive than other methods. For example, the bubble leak testing. So as I mentioned, if you go to the vehicle repair shop, so they'll do this soap bubble leak testing. They'll just pressurize the tire and they'll dip in the soap water, and they'll see the bubble formation and they can easily locate it. But when you go with the mass spectrometer, this is a completely different instrument, and they can able to detect a very small levels of leakage rate. So in the exam they used to ask one question on this, like which one is the most sensitive among all these. So they'll give all these options like bubble leak testing, conductivity testing, and pressure change and mass spectrometer. Which one is the more sensitive? So more sensitive is a helium mass spectrometer. And they'll ask few questions on this: why we are using helium, why we cannot use a hydrogen, why we cannot use other elements, because helium is inert gas, so it won't react with other chemicals. So like ideal character, like it won't react with other chemicals and it won't create any disturbance. So it's a completely inert gas, and moreover it is a lightweight. If you see the periodic table, hydrogen, helium, lithium, boron, beryllium, so it's a second element in the periodic table, lightweight. And in the nature also we have this helium. Best example is helium balloons, like birthday parties, all these things we used to purchase, right? The helium. So if you fill the gas, so if you leave the balloon, so it can escape because lightweight. Okay, so based on the requirements, so you can apply different NDT techniques. Accumulation test. So sometime like your devices may not detect, like for example everyday small amount of gas is leaking, but your sensor is not able to detect it. But if it is inside the confined space or inside any cabinet or enclosure, so over a period of time, maybe after 10 days, so the total accumulated quantity is reaching the measurable quantity, then your device will start giving the signals. So that is over a specified period of time. So if you monitor for 5 days or 10 days, maybe the quantity reached that measurable signal quantity and you got a signal. So audible leak detector, so this one is like a gas meter. So like if they have any dangerous gases, so it will produce the alarm. So this is a very simple one. So most of the safety people, they use these kind of detectors. Even when you are going inside the confined space, maybe your team, one person of your team member will wear this gas detector. So this will produce the audible sound. And even if you see some of the survey meters, all these things, so they'll produce the sound. So alarm meters or any portable warning devices. So bubble immersion test. So this is the one very popular one. So every time we used to see this one. So best just pressurizing the component and apply the soap solution or immerse that part into the soap solution. Then we can see the bubble formation at the site of the leak. So immediately they can pinpoint this and they can correct the repair. Like cycle repair shop, same thing. So they'll identify the location, then they'll fix it. So differential leak detector, so this is like a pressure differential, so they'll create the pressure differential and they'll see the difference. There were many techniques, but exam point of view, they used to ask mainly on a helium mass spectrometer. So there is a process called as a diffusion process. You can see that the gas actually migrates to the crystal lattice of the substrate. So this is a kind of diffusion process. You see the ink drop, slowly it will diffuse and you will get a different chemical. So this process we call as a diffusion process. Even the tea making also is a diffusion process. Then permeation. So in the exam they used to ask one question on this. Permeation is nothing but penetration of permeate, such as a liquid, gas or vapor, through a solid barrier. So sometime when you purchase the balloons, what happens? The first day it is full of gas, but after 2-3 days the gas is escaping. But when you check thoroughly, there is no leakage locations. There is no chance of leakage of the gas, but some quantity of gas is leaking, because even though it is small in size, all these things, but they have a thick barrier, like a rubber barrier, all these things, but still the molecules trying to escape through that barrier. That is what we call as a permeation. You can see even you have a membrane, that is nothing but the plastic layer, but still the gases are escaping, the small molecules are escaping. So that is what we call as a permeation. Then the discharge tube detector. So sometime like you can fill these kind of devices with a gas. So if there is any leakages, so when the gas is interacting with this, so it will produce some kind of color sparks. Then they can check the discharge, all these things. Then they will tell, okay, there is a methane gas leaking or carbon dioxide leaking. Then dynamic leak testing, so you can monitor for continuously. That is what we call as a dynamic. Static means like there is no variation. Dynamic means with respect to time it is changing. So flooded system, so it will filled with a gas, tracer gas, something like this. Flooded system, so they want to test whether this area is leaking or not. So here like if there is a leakage, so the other side you can see the water spots, but here the sealing was very good, so there is no leakage on the bottom side. Then halogen, so any element of the family of the elements like a fluorine, bromine and iodine. So these chemicals we are using as a tracer gas. So that particular technique we call as a halogen diode leak testing. So halogen leak testing. So they using these gases as tracer gases. Why we need to use these gases? Because so if the gas is escaping, then only we can able to detect it with our detectors. So they will create the pressure differential, and when the gas started leaking, then with the help of devices they can able to detect. So something like this, chlorine gas. Okay. But sometimes these gases are very dangerous. Then a halogen detector, so a leak detector that responds to halogen tracer gas we call as a halide leak detector, meaning when you are dealing with these halogen gases, that particular leak detector we call as a halogen leak detector. And there is one more technique called as this copper flame detector or halide touch. So what happens, they'll put a flame here. So when this flame bring to the near leakage areas, what happens, when the leakage gas when interact with the flame, and the color of the flame will get changed. Based on that, then we can tell like there is a leakage. But when you see this one, we are playing with a naked flame, so this is extremely dangerous. So that's why, so in industrial application they will not accept this kind of testing, because we are using the flame to test the leakages. So very very dangerous, right? So how exactly happens, but some places like maybe the offshore facilities or some places they'll install this kind of thing. So if any like other gases interacts with this flame, the color of the flame will get changed. Based on that, they can ensure there is a gas leakage. Then tracer gases, so you need to ensure the gases should not catch fire, because uh, if by mistakenly if someone is smoking or using the naked flames, and when we apply these tracer gases they will catch fire and leads to accidents. And hydrogen is especially very very dangerous, because it can be interacting with other chemicals and highly reactive, and it leads to combustible mixtures, leads to explosions, or leads to create some kind of reactions. So that's why hydrogen is not recommended. So in the exam they'll ask one question on this, why hydrogen is not recommended. Because of this, hydrogen is chemically not inert, so it is active and it reacts with other chemicals and produce some dangerous situations. So how we can prevent this? Like we need to ensure the system is free of hydrogen and other dangerous chemicals. So that's why before performing the leak testing, so we need to patch with NDT nitrogen gases, so that any other chemicals, so it will be escaped, and then after you can fill with your medium and you can inspect. So the purging with the nitrogen is important. So most tracer gases are non-toxic. So if we inhale little bit also, it will not cause any health issues. And adequate ventilation is always required, so that there will not be any accumulation of the gases, and there won't be any like safety related issues. So they use a forced ventilation, and they'll like exhaust fans kind of thing, and they will remove all the gases. So care must be practiced using with the face shields and loose fitting gloves when handling liquid nitrogen, and used to cold traps. So if you are dealing with the liquid nitrogen systems or cryogenic systems, to inspect any components for brittle fracture related things. So those are all like using the liquid nitrogen as a test medium. So in that case, so we need to use the face shields and gloves So before a system is leak tested, it is very important to verify that it is properly assembled and will not leak large quantity of tracer gas. So before you want to test, you need to double check everything completely fixed, completely closed. You need to shut everything off. Then after you can go for actual testing. Then coming to the helium leak detector, so the name itself is saying, so we are using helium as a tracer gas. So hermetically tight seal, so a seal which doesn't exhibit a leakage, like if you see some systems are very tight seal. So some kind of packages like medicines, some kind of injection bottles, all like sophisticated items, so they'll do uh, tight leakage systems and some kind of food package system also, so nothing will leak out. So that is what we call as a hermetically tight seal. So hood test, so enclosed by hood. So hood means best example, if you see your kitchen area, so what happens, this is your kitchen, so when you start cooking something, so on the top of this you have a hood, so any vapors, all these things, it will go outside with the exhaust systems. So this is a frame we call as a hood, so hood cabinet. Or even if you see the welding areas, so they'll use these kind of hoods so that all the fumes, everything will be exhausted outside. Okay, so these kind of things, so what they do here, so this is one kind of testing. So what they are doing, suppose if I want to inspect this component, so this is my test object. So for example, if there is no system, so what happens when I fill with helium gas, so when I maintain certain pressure, so what happens, the helium will confined within this box. But what happens if there is a leak, for example if there is a small leak, so this gas is leaking. But how I can measure this, so we need to use a hood system. So hood means like a box kind of thing, enclosed system, so that any gas leaking, so will be pumped towards this helium leak detector, and you can see the reading. So you can easily identify how much quantity is leaking, you can monitor and you can give the leak rate. So this is one technique. Then hydrostatic testing, so we are very familiar with this test. So most of the pipelines of the spools, everything, so once fabrication completed, they will do this hydrostatic testing. They completely fill with water and another liquid or any other gas medium, then they'll pressurize to different levels and they'll inspect. So sometime if the quality of the fabrication is not good, or maybe the raw material is not good, so leads to failure like this. Then mass spectrometer, so exam point of view very important. So we are not explaining this one in detail, so you can just watch a few videos which we uploaded to our app. So there were I think 10 to 12 videos related with the leak testing. So if you watch those videos, you can get a better understanding of the helium mass spectrometer working mechanism. But in the exam, they'll not ask deep level of question, they'll just ask only one or two simple questions on this. So one question is like highest sensitivity is this one, and you have two things, one is helium mass spectrometer, vacuum system and pressurized system. So there will be one question on that, like which one is more sensitive. So evacuated system is more sensitive, so like they use hood chambers kind of thing. So by reading the options you can easily realize like that particular technique is most sensitive. So that one sometime they'll ask one question. So what happens here, like capable of separating the ionized molecules at different mass for to charge ratio. What they're trying to say here, like if your gas molecules are having different mass and different charge, they call as a M by E ratio. For example, if you see helium, so helium is H2 4 and mass is like 4 and charge is 2. But if I take hydrogen, H1 so mass to charge ratio is entirely different. So your weight is changing, electricity also changing. Because of that, so when we apply a magnetic field, so the path, the circular path or the deviation taken by these particles are changing. So based on that, we can assume what type of gases are leaking and the quantity. So they'll use equipments similar to this helium mass spectrometer. You can see here, so what exactly is happening, you can see when you are sending these gases to the magnetic field, so what happens, so those having like lesser charge, less small weight, so they will take a small circular path. and maybe the weight is higher, so they'll take a path like this. Best example, if you go to a ground, so you see people so who are very fat, so what they do, they'll slowly take outer one, but who are very thin, so maybe they'll go complete round like this. So fat guys, maybe they'll take only small circle. So fat guy will take a small circle, but a thin guy will take a lengthy circle, meaning like the perimeter is different. So here also based on the mass to charge ratio, so we'll get different circular paths. So based on that you can easily assume like how much quantity is leaking. So depending on your applications and depending on your exact needs, so you can choose your equipment and the leakage rates and the model, particular models and pressure or vacuum systems. But in the exam they will not ask all these things in detail. So then next one is the pressure difference. So difference between the pressure also will cause a leakage. So if you see the second type, so how you know the air is leaking? Because of the pressure difference. So inside is a high pressure, outside is a low pressure. Sometimes they can make audible sound also. Then pressure testing, so filled with a liquid dye or a fluorescent oil, and then outside they'll just apply the developer and they'll look for the indications. So sometimes they can immerse in a liquid of dye or fluorescent oils, then they will see the other side with a UV lamp. Then if they found any fluorescent indication, then they will call for repair. Then pressure evacuation test. So most of the items are either go of pressure for a period of time, so something like a hydro testing kind of thing. So they'll pressurize and they'll maintain the whole time and they'll inspect, and they'll do it in a sequence. They will not directly jump to the test pressure, so they'll go with either 50%, 65, 70, 80, and finally they'll go with the test pressure. Pressure testing completely filled with a gas or liquid, which is then pressurized. Probe means like some kind of devices like sensor, we can call as a sensor, so directing or collecting a stream of tracer gases. So for example, if you have a gas cylinder, so if you think this gas cylinder is leaking the gas, so what we can do, we can use a small device, we can put nearby and we can detect. That is what we call as a probe. Probing medium is nothing but here detector. So here the gas is a tracer gas. So best example in the kitchen, so we are using our nose as a probe, so we used to smell, right? Sometimes if we feel like a gas is leaking, so with the help of our nose we can double check and we can rectify that. Then the probing medium is nothing but a tracer gas. So if it is a pressurized system, you may need to fill with the pressure gas, and probe test is mostly like for localizing, and you need to pinpoint the individual leaks. And there is one more leak system is the radioisotope leak system. So what they do, they'll fill with the radioactive tracer gases, so for detecting the measurement. One second. So sensitivity of leak test. So sensitivity, they will ask one question on this. Sensitivity means the ability to detect a smallest leakage rate, like how much small quantity is leaking. So if you go to the repair shop, I told you right, like one bubble leaking or maybe 10 bubbles leaking per second. So based on that, they can tell the severity of the leakage. But if you go industrial environment, they'll say like one bubble is leaking for 5 years or 10 years. So the sensitivity is increasing, or the equipment capability is increasing, so they can able to detect a very small leakages. So that is what we call the sensitivity of leak testing. Then coming to the standard leak, so we need to tell this leakage quantity. That's why we need to use a calibrated leak standards. So especially the best example are nothing but your gas detectors. How we know that particular device is leaking the methane gas or any hydrogen sulfide gas, all these things, because we ensure that gas detectors were calibrated. So what exactly they do, they use these kind of calibrated leaks and they purposely leak a small quantity of gas, and they'll test whether the instruments are properly working or not. Even if you see your survey meters also same thing, so they purposely keep near the radiation levels, so they use a cesium 137 or something, and that particular isotope is leaking the radiation, and they'll sense with these survey meters, and they'll adjust the, the the instrument, then they'll give a calibration sticker. Then time to time we need to monitor our devices. Okay, so this is the one calibration standards. So then ultrasonic leak detector, so you can use ultrasonic devices. You can because ultrasonic is nothing but sound. Like sometime if the gas is leaking or water is leaking or any liquid is leaking, so it may produce some kind of sound because of the turbulence or because of the cavitation. So you may feel like some sound. So sometime it is audible, so you without using any devices you can listen to its sound, or sometime you can use microphones, then you can listen to the sound. So this is what we call as ultrasonic leak detector. Especially if you go to hospitals, like during the pregnancy, they'll check the heartbeat, all these things. Some kind of ultrasonic probes they use, and they can even listen the sound of the heartbeat, all these pumping systems. So vacuum testing, so this is one famous method in the shipyard. So most of the time, so they want to ensure the tightness of the weld, so they'll create an artificial vacuum, and they'll apply the soap solution, and they'll see the formation of the bubbles. So here what they do, they'll create artificially the evacuation, and they'll apply the tracer gas on the outside. So if there is no leakage, there is no bubble formation. But if the weld quality is not good, so the gas is leaking, air is leaking, it will produce the bubbles. That is what we call as a vacuum box testing. So you can see here, so create artificial vacuum. So we call as a helium mass vacuum box testing. So they will ensure the vacuum. So before this placing this box, what they do, they'll apply a thin layer of the tracer gas, nothing thin layer of soap solution. So then after they'll create a artificial volume. So if there is a leak, so they can see the bubbles, and that's why this is fitted with this lighting. So we need to have a good lighting levels, and also the operator must be qualified, and he need to have a good eyesight. So that's why if you see in SNDTC 1A, so they need to follow the Jagger 2 requirements, or if the system is a CP189, so they need to be tested for Jagger 1. So must be tested for vision. But most of the companies whom doing this leak testing, they never test the candidates eye test. So they don't perform any eye tests. They don't have, the candidates don't have any certificates, but the company will do leak testing for several years. So vacuum testing, so the object under the test is evacuated, and the tracer gas is applied on the outside, like here the soap solution. When you create the vacuum, so because of the pressure differential, so if any leakage, you can see the bubble formation. Then coming to the comparison of the sensitivities, as I told, mass spectrometer is a very highest sensitivity, 10 power minus 9, and the radioactivity is also higher, but sometimes compared to this, mass spectrometer is even higher, so depending on the equipment. So if you consider industrial applications, so mass spectrometer is the highest. So what they do, they'll give a bubble leak testing, and thermal conductivity, halogen, and mass spectrometer. They'll ask which one is the more sensitive. But if you see the options, you feel like a halogen mass spectrometer is the highest sensitivity, so that would be the best answer. And radioisotopes, like the wipe test, they call us a wipe test. And even if you've seen during the corona, so people used to do the swab test, that is a kind of test similar to this. So what they do, they'll just do the wiping, and then they'll send the sample for the contamination or leakages. Tracer gas, so we can use a variety of gases as a tracer gases, so like carbon dioxide, argon, nitrogen. So but industrial applications, so we are using the refrigerants, like these kind of gases. Best example where you see these during the maintenance of your air conditioner. So if you call the AC technician, so they bring these kind of cylinders, and they'll fill the cylinders. These are all like a freon gases or some kind of refrigerants. Okay, so you can see these are the names. So they'll use a trade names like R22, R134A, R21, R11. These are all called as a CFCs, chlorofluorocarbons. Chlorofluorocarbons. So you have chlorine, fluorine, and carbon. Okay, so they are called as with the name as a represents, and in the exam they'll ask one question on this. So which one is allowed to use as a tracer gas? So in the options you may found this R12, or sometimes maybe they'll put R21. So that is answer, like that gases we can use as a tracer medium. So if you see the chemical formulation, so they are called as a CFC, chlorofluorocarbons. The problem is when they interact with the stratosphere, so they will damage the ozone layer. So ozone actually helping us to prevent this UV radiation reaching our earth surface. But when we use too much of chlorofluorocarbons, like if you use too many ACs or ETC, so they will damage the ozone layer. So they'll ask one question on this. So what type of gases will damage the ozone layer? So refrigerant R12, R21, R134A, these kind of refrigerant gases will damage the ozone layer. So then halogen tracer gases, same thing, CFC. So R refrigerant 22, R22, R134A. And when you are dealing with the radioactive leak testing, so radioisotope leak testing, we can use a krypton 85 as a tracer gas. So but in the exam they will not ask, but we just need to have an idea. So we are using a krypton 85 as a tracer gas for radiation leak testing. Then coming to the techniques, so you have very high number of techniques compared with any other NDT method. If you see at electromagnetic testing, you have only few techniques like eddy current, remote field testing, alternating field measurement, pulse eddy current, only few methods. But when it comes to leak testing, so you will have hundreds of leak testing techniques. So you can see halogen detector, helium mass spectrometer, infrared ionization, so many techniques. Okay, but in the exam they may focus mainly on this helium mass spectrometer. So there are totally three different type of techniques. One is a tracer probe method, another one is a detector, and the third one is a hold mode, and fourth one is a bell jar mode, fifth one is accumulation. So you can see here when you're dealing with a pressurized vessel, so meaning like if your system is already filled with a gas, best example your gas cylinder, like for example now if you went to your kitchen, so you can see easily there is a gas cylinder. Then how you know the gas is leaking or not? So by using our nose we can smell, we try to smell it near the cylinder, and if you feel some bad smell, maybe we'll say the gas cylinder is leaking, or if there is no smell, then we'll say no, the cylinder is in good condition. So why? Because the cylinder is already pressurized with the gas. So if the cylinder is having any small leak, so it will easily escape out because of the pressure differential. So that's why, so the system under pressure, so need to be scanned with a device called as a detector probe. So what they do, just we put a probe here and we scan here and here. So just entire on the cylinder, so we can scan manually and we can check. So that is what we call as a detector probe technique. So we can use a helium as a tracer gas. Why? Because helium is of small in size, in the periodic table it is a second element, and readily available and inexpensive in nut gases. It won't react with other chemicals and non-toxic. So you can see here there is one more system, is evacuated system. So previously we seen pressurized, now is a vacuum. So what they do here, so this is my object inside. So what happens, so I'll try to create a vacuum. So meaning you are trying to pump the gases out, so creating artificial vacuum. So here what we do, we spray the gas from outside. So if there is no system, then you won't see any reading. But if there is a leak, so what happens, the tracer gas will enter slowly inside and you can able to see the reading on the screen. So by that reading we can able to tell the severity of the leakages. So two things, one is either pressurize the cylinder and use the detector probe, or otherwise create a vacuum, then outside you spray the gas. So ultimately you need to have a medium that is nothing but a tracer gas medium, whether you are applying with the pressurization process or whether you are creating a vacuum and using a tracer methods. So ultimately we are trying to check the leakage of the gas. So you can see here there is one more technique, is a hood technique. Good technique of leak testing of evacuated component, just now we seen, right? So this is a system under evacuation. So what this guy do, he will try to send the gas here. So everywhere is filled with the gas. Okay. What happens if the system is having any leak, so the gas will enter inside through the leak and it will reach the meters, then you can able to see the reading on this. This is a bell jar method, so you can close it, you can create a jar method, you can close the system and you can get a better reading. This is what we call as a bell jar method. This is also the see good system. Then you can use a variety of leak standards, so depending on your needs you can use a different calibration standards, and you can ensure that you met the required sensitivity levels. Sometime if you don't do a proper way, then you may get some leakages because of the manual issues, the operator doing some mistakes, all these things. That one we call as a virtual leak, so not associated with actual leak. This is not coming because of the leak, because of something else, so you are getting that leaks. So something like this, right, when the screwing system is not proper. Okay, then units. So units are very important, different countries they use a different systems, some countries we use a pounds, psi, some places they use a bar, some places they use a atmospheres pressure. So units are very important. If you don't know the conversions, what happens, so unnecessarily we create a problem, instead of using 40 psi, maybe use a 100 bar, maybe high pressure leads to explosion. So that's why the units, system of units are very important. Okay, so this we completed leak testing.